Welcome to another edition of Daily Airline News focusing on the loss of Air India Flight 171. I'm Geoffrey Thomas and delighted to say joined by my co-host Richard Godfrey in Frankfurt. Good afternoon to you, Richard.
And good evening to you, Geoffrey.
Thank you. Viewers, this episode is Openness and Integrity. It's episode 254. And let's start off with Andy Beckett, 4480, who says, "Hi, gents. I wholeheartedly agree with and support your thorough investigation of this incident. In the case of Air India 171, it is clear from the preliminary report and other public events that evasion and misinformation has already begun at an early stage. If one were to await the final report, it seems more than probable that it would prove to be a travesty, in all likelihood blaming the captain. From the many examples you've cited today, it is clear that it can be naive to rely on official reports in some cases. You gentlemen, by embarking on your investigation at an early stage, have, in concert with others, presented the Indian AAIB with an open challenge to complete their work with openness and integrity, or else be seen to be motivated by considerations that conflict with the truth." And Richard, we have thank you messages from Yoda Be It 1 1746 and Joe Costa 1298 for your clarifications yesterday. Joe also adds, "I do not believe these pilots, as have been implied by the Indian AAIB, intentionally caused this disaster. There are just so many layers to this onion, and it is too easy and convenient to assign blame to the pilots. All evidence we have to date, including the rapid cleanup of the crash location, compels me to believe that a cover-up by the Indian AAIB is being undertaken. I hope I am wrong, but only the release of the data you have called for will answer all our questions. Please do not stop. Please continue applying pressure and keep this investigation alive. Thank you, and Geoffrey, again, for your superb work." Richard, compelling comments.
Indeed, they are. And there are three petitions currently before the Supreme Court in India. The first one is a public interest litigation by Safety Matters Foundation seeking an independent investigation, and that should be monitored directly by the Supreme Court. And they challenge the conflict of interest between the DGCA and the AAIB in conducting the probe jointly. And the Supreme Court has issued notices to the government, the DGCA, and the AAIB. The second petition was brought by the father of Captain Sabharwal, and he's the first petitioner. And the second petitioner on the same petition is the Federation of Indian Pilots. They allege the investigation is flawed and are seeking a new inquiry body. The petition challenges the AAIB investigation as biased, incomplete, and technically unsound. And the court has been asked to close the current AAIB probe and transfer all evidence to a court-constituted inquiry and led by a retired Supreme Court judge and independent aviation experts. And they explicitly argue that the captain is being unfairly blamed without a proper technical analysis. And then there is a third Supreme Court intervention, a letter petition from the BJ Medical College, which is looking for compensation for those families of the victims. What really disturbs me is the second petition, because AAIB officials visited the captain's father home on the 30th of August and conveyed insinuations that his son was responsible for the crash. And they based that on their CVR analysis. And the petitioners argue this amounts to a gross and calculated overreach of the AAIB mandate, and alleging the probe has been compromised by early pilot error narratives. The petition does not claim, however, that the AAIB formally concluded the captain deliberately crashed the aircraft. In its published findings, they do not come to that conclusion. And it rather alleges that the AAIB is implicitly or prematurely attributing blame based on the CVR and switch movement before a full investigation is completed. And I find it particularly disturbing that the AAIB visited the captain's father in breach of the normal protocol, where the Air India Family Assistant Unit appoints a coordinator who should be informed and present at such a meeting. And the Air India Family Assistant Unit ensures medical and counseling and financial support to victims' families. They have a dedicated liaison officer to coordinate each case. But this visit by the AAIB with the captain's father, they weren't informed and they weren't present. And then there's another issue which bothers me, and that is that 3 DGCA staff members are involved in the AAIB investigation team. And the ICAO state in their regulations, the Accident Investigation Authority shall be independent in its organization and functionality, separate from the state aviation authorities and other entities that could interfere with the conduct or objectivity of an investigation. So you have to ask the question, why are the AAIB breaking both the Indian regulations and the international ICAO regulations? It makes you wonder whether they're pretty desperate to try and make their case.
It is very interesting that, Richard, because you and I have been following air crashes for decades, and one of the things that comes out over and over again that is the American NTSB is always at loggerheads with the regulator, the FAA, over improvements that should be made and are not made, and they're always at loggerheads. So to have the FAA involved in an NTSB investigation would simply be completely off limits. It's quite
Yeah,
a stark contrast.
it is a very stark contrast.
Mm. So, Richard, talking of contrasts, we have a contrasting view from Dublin, German, 2233. You're going to love this one. Respectfully, Geoffrey and Richard, your framing here misses a key distinction between constructive independent analysis and premature speculation. Every example you cite, Comet, Erebus, Silk Air, Air France 447, was ultimately validated through data access and physical evidence, not guesswork or online theorising before investigations concluded. Outsiders may highlight inconsistencies, yes, but their findings only become credible once verified by official authorities with full access to black boxes, wreckage, and lab resources. What's concerning is the implication that every government hides the truth or that independent sleuths are inherently more trustworthy than trained investigators bound by ICAO Annex 13 standards. That narrative fuels misinformation and public distrust long before facts are confirmed. Air India's 171 preliminary report may have gaps, but that's exactly what a preliminary report is, an earlier snapshot, not a final conclusion. Demanding truth before evidence is analysed isn't investigation, it's advocacy. Real progress in aviation safety happens when independent insights complement official work, not when they undermine it. Richard, before you chime in on this, I totally disagree with this. And it appears that ICAO Annex 13 means nothing to the Ethiopians or to the Chinese. And Kevin and Susan Campbell's work in New Zealand overturned the US NTSB, which said the cause of United Airlines 811 was a ground handler. And it wasn't, it was a cargo door malfunction. So what is worse, the official investigation also becomes the basis of any legal cases, thus potentially robbing the victims of proper compensation. Now, Richard, you can have your thoughts.
Yeah, well, Dublin German accuses us of premature speculation, guesswork, and undermining aviation safety. Well, pretty powerful stuff.
Yeah.
We have published a series of reports laying out all the evidence for our, firstly, plausible hypothesis, then it became a probable cause, and then finally we issued a report entitled The Root Cause of the Crash. We've also published the entire maintenance history of the entire Air India Boeing 787-8 fleet. We've also published TV interviews we've given discussing the crash with aviation experts. It's on BBC, CNN, Indian TV, and other national TV channels. We've published slow motion videos of the crash flight. We've presented satellite imagery of Air India Boeing 787 aircraft parked up long-term in maintenance facilities. We've published the ADS-B data from Flight Radar 24 for the crash flight. We published the flight and maintenance logs for the crash aircraft, VT-ANB. In fact, in total, in the last 138 days, over 1 gigabyte of data has been published. And hundreds of viewers have downloaded the papers and commented in detail on each one. And hundreds of viewers have contributed as pilots or engineers or aviation experts. And there are people working for Air India currently, or Boeing or GE on the 787. And family members of the victims of the Air India crash and their legal representatives have contacted us and thanked us for our detailed work. Then along comes Dublin German, and he's one of a few who prefer to run a misinformation campaign against us and an assorted attempt to try and discredit what we're doing.
Well, just let me add one more comment here, Richard. This particular comment from this gentleman really upsets me. I've been covering aviation for 50 years. I was the Southeast Asian editor for Aviation Week and Space Technology. I was the senior editor for Air Transport World, the world's #1 airline management magazine. And I founded Airline Ratings, Safety Rating Airlines, and I ran that company for over 11 years. And I can tell you, I can tell Dublin German, and I can assure all viewers, there's one common thread through all my coverage of aviation, and that is manipulation of crash reports by governments, by airlines. It just goes on and on and on, and we could dedicate 10 episodes to it. So if Dublin German or some viewers believe that airlines or governments follow ICAO Annex 13, they're dreaming, because they simply don't. That's all there is to it. So I've had my piece. Let's get back to Air India 171. Jean Malvez 985. Dear Richard and Geoffrey, a naive question on aviation dummy. Are there pilots in the cockpit able to hear the turbine engines? and estimate at the sound if they are working well? Or can they estimate the thrusts of the motors by what they perceive in the cockpit? Can those perceptions influence their actions during takeoff? Or do they only act in the light of what they read on their digital instruments? Thank you again and again and again for your work. It's a very interesting comment, Richard, and a lovely thought.
Yeah. I think yeah, everyone who's sitting on an aircraft can feel the thrust of the engines at takeoff, and you can hear the noise as the engines wind up. But you can't measure the oil temperature, and you can't measure the oil pressure or the rotation speed or the vibration from the blades. So yeah, the answer to your question is the pilots do follow their instruments, which tell them all of these things. And the basic rules of flying are aviate, navigate, and communicate. And this hierarchy governs all flight operations. Aircraft control and flight path stability is always the first priority. And then comes navigation, and then you think about the radios. There are visual flight rules, which is for small aircraft, and then there are instrument flight rules, and the IFR or instrument flight rules are required for all commercial operations. So the pilot will use his instruments and displays for control and navigation, and he will not rely on external visual references. All airline pilots are instrument rated. A pilot will have visual clues and sensory perception of motion, of course, but is trained to use instruments and displays for the basis of the aviating and navigating. There is visual clues. Pilots do look out of the window. They even have a head-up display, which allows them to know what's happening with the aircraft at the same time as looking out of the window. And they have, of course, several head-down displays on the flight deck. And they will listen and they will hear engine audio cues, and they will hear if the autopilot or the auto throttle mode change tones come on the loudspeaker. They will get oral warnings, sometimes warnings like bank angle or pull up or wind shear. And they will have motion and orientation senses. Everybody does. And it's useful only in visual flying on a small private aircraft. It's highly unreliable without external reference and a known contributor to spatial disorientation events, which can unfortunately happen. Your body cannot always distinguish between an acceleration and a tilt. And airline pilots are trained specifically to distrust bodily motion sensations during instrument weather conditions or high workload events. On a 787, the head-up display and a head-down display allow a pilot to use his vision and hearing and motion sensors, and pilots must always pass a regular medical check and also a breathalyzer check before each flight. And they're all rated for instrument flight rules, so they can fly an aircraft purely based on what the instruments are telling them. And all commercial aircraft also have flight envelope protections. And the pilots particularly report three issues. They have a thing which they called the leans. When a slow bank is not detected, And when you correct back to level flight, the pilot feels like they're banking in the opposite direction when they're not. And there is another illusion called the somatographic illusion. And that's when acceleration makes you feel like the aircraft is pitching up, and deceleration makes it feel like the aircraft is pitching down. And these illusions have contributed to multiple accidents, especially on takeoff and go around when visual cues are limited. And then the final illusion is called the Coriolis illusion. And that's when you turn your head during a turn and it gives you a false sensation of tumbling. So pilots are aware of all of this and are trained to take that in check. And then there are all the protection systems on an aircraft. A Boeing 787 has overspeed protection, stall protection, bank angle protection, load factor limiting, pitch attitude limiting, thrust asymmetry compensation, tailplane stall protection. And Boeing allow the pilot to override these protections. Airbus has a different philosophy, and we will be coming back to that tomorrow because the distinction between the Boeing and the Airbus philosophy is quite important. And I personally adhere to the Boeing philosophy. The pilot in command always remains in command. And tomorrow's episode, I encourage you to watch. It'll be very interesting, and it's about an Airbus incident.
Yes, and just going on from those sensations, I can add a little bit to that, Richard. I had the privilege of visiting the American aircraft carrier, the USS Carl Vinson, and I did a catapult takeoff in a Grumman C2 transport. And when you are catapulted off an aircraft carrier, the sensation is you're going vertical. And in fact, you're not, you're going forward, but you're going off with such force, the sensation on your body is a vertical sensation. So it's quite an interesting, and then all of a sudden it changes to a normal sensation of flying. So quite an interesting phenomena,
Yeah.
and you can
Yeah.
be certainly tricked by these forces. So CJF 888, regarding ETOPS, they still allow some flights to cross the Atlantic with an in-op APU, that's auxiliary power unit. I flew from LAX to Heathrow on an American Airlines 777-300ER with an in-op APU. They wouldn't let us board for a while until the cabin temperature was acceptable using the power cart. There was no pack air until the engines were started. Richard, your
Yeah.
thoughts?
I've traveled the Atlantic many times. Not necessarily just an in-op APU. I've had one engine in-op on a 747 on two occasions, and we got diverted to Shannon in Ireland.
Mm.
On the Atlantic run, you will find CJF that they probably altered the flight plan to minimize the distance from a nearest diversion airport, should they need it. So flights from LAX to LHR usually head northeast over Canada, over the Hudson Bay, over Greenland, and then come down into the UK. And the flight routes such a in-op APU case would probably deviate, go via Chicago, over Toronto, Gander in Newfoundland, maybe even over Shannon in Ireland to the UK. And sometimes, quite rarely, you will actually find flight routes change to go over Gander in Newfoundland, then over Greenland, then over Iceland and Reykjavik airport, and then come down over Scotland into the UK. I think the similar happens in Australia, Geoffrey. You've had
Yeah,
experience of that there.
absolutely. Well, in Australia, when an aircraft are not ETOPS compliant, the flights across the country from Sydney and Melbourne to Perth will take a northerly route to fly close to Alice Springs and avoid the Great Australian Bight over the ocean. And that happens every now and again, probably half a dozen or a dozen times a year. So people sort of get on social media and say, "How come I'm flying over Alice Springs and the flight took an hour and a half longer?" Well, that's the
Yeah.
reason. It wasn't ETOPS compliant. So, yeah. So, screwdriver 5181. Before joining the railway equivalent of the AAIB, I used to design electronic safety critical equipment for trains. This had to be coated so that if necessary, it would run when soaked in condensation. It seems incredible that aircraft equipment is not so protected. Thanks for an incredibly interesting analysis of this disaster. Richard, that's an interesting comment.
Yeah, and aircraft equipment is also consistently coated, sealed, and engineered to withstand condensation. And if aircraft equipment is protected, you will then ask, why can moisture still affect the EE bays? And unlike a railway, aircraft regularly go from hot, humid ground air, is the case in Air India's Flight 171, for example, to cold, dry air at altitude. And then it goes back again to the hot, humid ground air. And what this does is creates sudden temperature swings, moisture cycling, and repeated formation on surfaces. And no coating or seal can completely eliminate condensation across all conditions. And EE bays are ventilated with conditioned air to cool the electronics. Even though this air is filtered and dried, it still contains some humidity. And over many flights, small amounts of moisture can collect, and water can drip or pool in awkward places. Connectors and wiring can be exposed, and cooling systems are essential, but they also introduce air that can carry moisture. EE bays do have drain holes and moisture traps and water separators, but in real operational world, dirt and dust and insects can clog drains. And heavy rain or washing an aircraft even can introduce more water than expected. And icing conditions can temporarily block drainage. And over the years, seals harden and crack, coatings wear down, connectors loosen slightly, insulation ages, and this all creates small openings where moisture can enter and cause trouble. And some parts cannot be fully sealed. Moisture in an airframe can travel much further than some people expect. And aircraft are full of hidden pathways where water can run into EE compartments. And there is, bottom line, no substitute for regular inspections on an aircraft.
Now, Richard, I've got a curly one for you from Doug Swanson, 9142. He says, "Hi, Richard. At the 33.15 mark, that was in the episode, I know you've been reading my comments and understand what I've been commenting on for some time now and multiple times. Curious as to why no mention of the main battery as a possible cause of the missing battery backed standby 28-volt DC power. It could have been due to a shortened condition and also could have been due to a discharged, depleted battery that can be disconnected for battery protection from the plane's hot battery bus and instrument buses. Here again is a recent comment where I tried to summarise what happened. Battery overly discharged, depleted, or some other problem. Standby DC power lost. At takeoff, loss of standby DC power detected in flight mode, RAT deployed. Fuel switches cycled in response to RAT deployment. Fuel switches in cutoff position takes all engine generators offline. Fuel switches were returned back to run position quickly, but loss of standby DC power left the fuel control relays powerless and resulted in a 10-second delay back to run when the RAT power came online. Pilots were not the reason for the delayed time back to run for the fuel control switches. Your thoughts, Richard?
Yeah, well, thank you for that, Doug. We do try to read all the comments. In fact, we discussed your reference to the Boeing 767 documentation in episode 215. And in episode 220, we discussed your theory. And I stated in that episode, Doug, you could be right and I could be wrong. The main battery is a backup system. The APU battery is a backup to the main battery. And the RAT is a backup to the essential AC and DC systems. The engines normally supply the aircraft AC and DC systems, and the APU is a backup to the engines, can also supply the aircraft AC and DC systems. And we recognize the electrical architecture of the Boeing 787-8, and it has a very full redundancy and built-in backup systems and layers of backup systems. And that's by design. And what we're looking for is a reason for a near simultaneous dual engine shutdown. And as you say, the loss of the main battery will not cause a dual engine shutdown. And as you say, the fuel switches will cause a dual engine shutdown. However, the switches, you point out, were cycled in response to the RAT deployment. And I agree with you on that point. And the RAT was deployed before the engines were shut down and not in consequence. And you then say the fuel switches will take all engine generators offline. Now, that is true and what normally happens. But in the scenario we're put forward, we're saying that the captain and first officer instrument DC buses were both compromised. And in that case, you can move the fuel switches like you want, but they won't have any effect. And the engines will be shut down for another reason. And that is if the data link between the cockpit throttle levers and the EECs is lost. And in my view, the engine shutdown was because of a temporary short circuit in both DC buses, which caused a temporary data link failure between the thrust control module and the engine EECs. And Dr. Thomas of MIT Engineering Systems Lab pointed this out back in 2016. And in my view, the temporary electrical short was due to water ingress into the aft EE bay. And the FAA have pointed this problem out in 2016 and again twice this year, once before the crash and once after the crash. So my view is backed by MIT and the FAA, and I think on the weight of evidence, I have to slightly disagree with your conclusion, Doug.
Nils Sweden 8480, Richard. He says, if I understand your previous posts correctly, the accident must be due to a design flaw, something the manufacturer and aviation authorities should be blamed for. Yes, the maintenance is not good, but that is not the root cause this time. I don't think we'd agree with that one, Richard.
No, I'm afraid we don't agree with you, Neil. And by the way, that's not what I said. So your understanding is not correct. What I said is the root cause was water ingress into the aft EE bay, and we pointed out the maintenance failures across the entire Air India Boeing 787 fleet of aircraft, and it was definitely poor. We pointed out the maintenance failures on the aircraft involved in the crash, VT-ANB, and we went back over the last 3 years. And the DGCA has found multiple non-compliance issues by Air India and levied fines. We have said if there was a design flaw or manufacturing defect, then there would have been a service bulletin from Boeing or an airworthiness directive from the FAA as a result. But there hasn't been. And we have made a recommended FAA change to the regulation because at the moment, Boeing and GE comply with the current regulation. Others have accused us that no amount of regulation or design can prevent inadequate maintenance from causing a disaster. We tend to disagree with that view. And in fact, Boeing and Airbus do an awful lot of work implementing redundant systems and backup systems and protection systems to prevent disasters from happening. And they are succeeding because air travel is becoming safer and safer. And I have to say, in my view, the Air India 171 crash was not due to a design flaw. It was the result of long-standing systemic failures in the maintenance of the aircraft.
Yes, some very interesting questions, Richard, from our viewers.
Indeed, they are.
Yeah, and very probing. And hopefully, we've answered them for you. Richard, thank you very much indeed for your work on this.
Yeah, you're very welcome.
And viewers, we have a series of questions from you about independent outsiders solving air crashes, and I'm sure you'll find those fascinating. They'll be coming to you later in the week. And tomorrow, as we have alluded to, we do have a very special guest tomorrow talking about an incident involving an Airbus aircraft. And I'm sure you're going to really be very, very interested in that episode. And I do urge you to tune in to that tomorrow. So, Richard, once again, thank you.
You're very welcome.
And viewers, thank you for subscribing. Thank you for liking us. Thank you for those wonderful comments. Thanks for the great questions. And we do look forward to your company tomorrow. Thank you very much indeed. Take care.